Today I'd like to talk a little bit about the use of volcanic particles in agriculture and gardening and the potential I see in using this on a wider scale. So this goes back to some interest of mine when working with volcanoes in various places of the world. And there I come across all sorts of interesting phenomena. And of course, volcanic rock has been used as primitive housing for many, many centuries, for thousands of years by humans. And it's widely used as a concrete supplement. It's actually very good. It's probably a little bit less of a CO2 problem than some other ingredients in concrete. And it's also still used widely as abrasive. You'll actually, if you have a whitening toothpaste, chances you have some volcanic particles in there. If you have stone-washed jeans, it's actually volcanic stone that's used for that. But I want to focus a little bit on agriculture and gardening. So I'm giving you some impressions here about primitive housing and caves stuck into volcanic rock. But there's a few bottles of wine from the Canary Islands that are grown on volcanic soil. And this is what I'd like to focus on. This is a phenomenon that's quite widespread. This is also in other parts of the world, like here, there's a bottle of wine from the Auvergne in France, and I put that in for Renault. And I still have the bottle at home, actually. I'm not sure it's any good any longer, but it's grown on volcanic soil, and it gives a lot of nutrients to the product that's grown on volcanic soil. Before we go into some of the Canary things that I outlined in the abstract, I'd like to take you to Indonesia. And Indonesia is a lush place. It's very fertile. It's traditionally the spice islands. This is where many of the spices come from. This is where pepper was initially imported to Europe. And it's fertile because it's warm, it's humid, and it has volcanic soil. So it's got these three magic components. And here's Merapi volcano, and you see the rice paddies, and then there's a little storm coming up on the right-hand picture, and you can sense how moist, how humid it is there. And this is the ingredients to grow all sorts of spices like chili peppers to make hot curries, for instance. But I should also point out it's one of the places where a lot of coffee is grown, and many of the coffees that you drink come from volcanic soil. And many of the coffees you buy here in Sweden actually come from this part of the world. Like I'm giving some brands here that all have Indonesian coffee contributions. And I should point out that 70% of coffee is grown on volcanic soil. So we all touch volcanoes almost every day once we have a cup of coffee. And here's some impressions of coffee plants and coffee plantations in Indonesia. And this was one of the cups of coffees I was served in one of these plantations, which was very nice. And here you kind of can trace the product from initial kind of harvesting the beans to how the beans are kind of separated, and then they're roasted, and eventually there's a final product, the coffee. But I should also point out that other products are grown on volcanic soil. Here is tea, for instance. And tea needs high altitude, and it needs a moderate climate. And of course, volcanic soil with a lot of nutrients is very good for that. Then cocoa beans. This is cocoa plantations in Indonesia as well that I visited. And here we have some cocoa pods, and then the beans in the pod. And many of the products that contain chocolate that we kind of consume here in Europe come from these parts of the world, and many of them are grown on volcanic soil. And some of the suppliers actually kind of make use of that in their advertisement. So here is some examples. One of the most favorite chocolate products in Iceland is called lava, and some of these other products here, they make use of this volcanic background that chocolate often has. Here's an interesting plant that's also grown in many parts of the world, and often on volcanic soil. Not sure whether you can guess what it is. So this is the plant when it's young. This is when it's grown a little further and when it's blooming. And this is when it's almost close to maturity. And well, this is the final product. So this is tobacco, and tobacco is nowadays having a big revival because it's no longer used for smoking quite so much, but it's used actually for nicotine products like nicotine gums and things like that. So now it's used to help people stop smoking, and it's also used as a pesticide, as a natural pesticide. So tobacco growth and plantations are still going very strong despite the downturn in using tobacco smoke by society. So, and here's Merapi volcano in Indonesia, and you can see the gravel in front of it. This is volcanic deposits, and this is what happens there. The volcanic deposits are actually quarried, and these are loose volcanic deposits. They come to rest in the valleys just on the slopes of the volcano. And what happens here is that people mine that, and they mine that for building, i.e. as a concrete supplement. They mine this for agricultural use as well as for hazard mitigation, because they mine this purposefully unevenly so that the new pyroclastic flows, the new kind of material coming from the volcano, will actually get arrested in those valleys. They create artificial sediment traps, if you will, so that the material will not travel quite as far from the volcano as it would without these rugged surfaces in the valleys. So here's just another example. It's a large scale thing. And this is kind of what I wanted to use as an introduction for Indonesia. But it's easy when you have loads of water. That's the point I want to make. And if you have the three magic ingredients, but if you go to other places in the world, you might not have all three ingredients. And this is where I want to kind of talk a little bit about the Canary Islands here, because in the Canaries, you have volcanic material, you have a warm climate, but you don't have a lot of water. And volcanic particles in agriculture have been used there for quite a while, and this is actually where the idea originates from, about using volcanic particles to supplement agricultural soils. So the topic here is really what happens if you don't have a lot of water. And I should point out here that the climate zone in which the Canaries are is considered very dry, as opposed to Indonesia, which is tropical. So here we can have a look what happens without a lot of water. Now, I want to take you to Lanzarote now, and it's famed for breathtaking volcanic landscapes, but it is very dry. So there's not a lot of vegetation there in those areas that have not been agriculturally exploited. There was a large eruption, actually a very long eruption, the 1730 to 1736 eruption, and it started with intense earthquakes already in mid-1730, and the eruption then really took off in 1731, and the Spanish king, he was very concerned, and he sent a bishop there to investigate the phenomena, and this was Bishop Davila y Cardenas, and he arrived there in 1731, and he ordered the villages to be evacuated. So most of the villages were shipped off to the other islands, and he was observing the events, and he noted something after a while. He noted that when lapilli, little stones, little volcanic stones, were produced as a thick cover over fields, then the vegetation died off. But if it was only a thin cover, the vegetation was actually getting stronger. There was a blooming effect. And this was something that he took very seriously. The eruption was quite devastating for the landscape, or the agricultural landscape there, because almost a quarter of the island was covered with lapilli and lava. But once the villagers returned, the bishop recommended that this finding is used. And what he did is he instructed people, he instructed farmers to use this kind of observation to their advantage. And they started to kind of use these tephra particles, that's the little lapilli, the little stony fragments that the volcano produced, and they used this to grow all sorts of cereals and wine. And this had an enormous effect on the island's economy. So here's just a few impressions. And as you see, it's a very barren landscape, but by using these kind of volcanic particles in a sensible way, the agriculture was really getting very strong there. And this is still used today. You can see that entire valleys are filled with these particles now, and that is where a lot of wine is grown and a lot of other products. The population actually doubled in the decades after the eruption, and up to 1780, 50 years later, there was a population of about 10,000 people living on the island, while beforehand it was actually less than 5,000. The products became so famous that even at the Vienna Congress, wine from Lanzarote was consumed. And today it's got there's a big revival. There's a whole kind of tourist culture now where people go and visit vineyards and that kind of thing. And they have a special technique of growing the wine. They dig them into these lapilli covers, into these little stones, and that protects them from the wind. And at the same time, it provides a lot of nutrients. And I'll talk a little later about that. So there's a whole economy centering around that now, the production of wine, and people can actually enjoy a bodega kind of holiday. You can book yourself into spending some time on a vineyard if that's what you fancy. So there is, however, a price to pay, and I have to be very direct about that. As in many cases, nothing comes for free. The price is that a lot of material has to be quarried, and it happens from pristine volcanic cones. And these then do look a little, well, at least in my view, a little ugly. So it's a spoiler in the landscape. And here is some kind of wild quarries and also some organized quarries. But as you see, I mean, it is not the natural features anymore. And this is a problem that the Canaries have to deal with. And given that tourism is a very big economic factor there, this is a real spoiler, I have to say. Now, I'm going to take you to one of the other islands, one of the larger islands. Gran Canaria has a much larger population. And Gran Canaria is also very dry usually, but by the use of this technique of supplementing the soil, there has been huge kind of strides, and there's a lot of bananas now produced on Gran Canaria. It's actually these white kind of greenhouses that you see. These are all tomato and banana plantations. Also, the volcanic particles are used for concrete supplement, and it's better than limestone in terms of CO2 release. But well, given that there is a large kind of city, Las Palmas, and the city is growing, a lot of material is also consumed in the building industry. So I've been visiting some quarries there, and here we have a pecan quarry, and then there's a sorting kind of station where the pecan is sorted. Pecan is a name for the small particles, a local name in the Canaries, where the small particles are sorted into those that go into the building kind of industry, those that go into agriculture, and those that go into gardening. And then they are kind of put on trucks and they're shipped out. And this is quite a big industry there. The downside is also visible on Gran Canaria, and here is one of the nice volcanic cones, and there's an Uppsala field trip from a few years ago in the lower right, and one side of the volcano is now completely open from mining activity, while just about 100 years ago, a little over 100 years ago, this was a pristine surface, as I can show in this old image from 1906 on the left-hand side. So, and again, in the landscape, you see many of these mining scars, and this is an issue that is something the tourist economy is now increasingly less fond of. So they're trying to avoid this. Many of the active quarries are now hidden, but the scars from the previous mining activity, they are there. They cannot be removed very easily. So I'm going to take you now to Tenerife, the largest island in the Canaries, and there was historical eruptions, and there is an image, a hand drawing from one of them. That's the 1798 eruption, and it produces little volcanic particles. The vents are spread along a triaxial rift system, so you have a triaxial rift on the island, and there's loads of these volcanic particles that you find there, and they're used on various levels to grow wine, to grow bananas, and this kind of thing. So here just a few impressions. So this is how these things look like in the field. You have these alignments of vents of little cones, volcanic cones, and they can be quarried, and they produce a lot of this picon. And in the lower reaches of the island, you have a lot of pumice, and here's some of the pumice deposits, and they have been quarried quite actively as well. In fact, the onions from southern Tenerife are quite famous, at least in Spain and the Canaries, because they grow these giant onions. And the giant onions, they actually grow in pumice. There's a secret that pumice provides, or there's a magic thing that pumice provides, allowing giant onions to grow. But again, it produces a lot of these scars in the landscape, as you can see here. And the picture in the top left is actually quite interesting, because this cone was owned in segments by different people, and each of them grew their own private little quarry. So here we have different kind of quarries on the same cone, and it looks rather peculiar on first glance. The problem is so severe that there is these descriptions going back to Humboldt, that he described 3 cones in the Orotava Valley in northern Tenerife, and he was apparently touched because of their magnificent beauty. But if you go there today, there's only 1.5 of those cones left. One is completely gone from quarrying, and the other one has a hotel on top. So these kind of landscape scars are the price you pay for the increase in fertility. I'd like to take you to La Palma now, which had a lot of historical eruptions, the last one in 1971. And there's some photos here from the 1949 eruption. And I also have some photos from the 1971 eruption. That's the ones here. And as you see, there's a lot of what we call strombolian activity. So material flowing through the air, getting fragmented. And that is how the fine kind of stones, the lapilli, are produced. So, and there's loads of it on the crest of the island, and people have started to use this. And indeed, what happens is then when there's new lava flowing down the hills, it creates these lava platforms, like I'm showing here for the 1949 eruption. There was a little platform created, and the local farmers were super quick in bringing in more of these volcanic particles and soil, and the entire platform is now an agricultural kind of field. And you see the little fields and greenhouses there. And it's not just the 1949 platform that has been converted into agricultural fields. It's actually all the platforms, the 1949 and the 1585, and many of these lava platforms are now full of greenhouses. Even the 1971 one is already to a large degree agricultural, and the government had to step in and say, stop, the rest is actually going to be a nature reserve to display the scientific processes. And now there has been a halt put to this, but this is very fertile land once you put the right ingredients there. So, and here I'd like to kind of give you a sense, and that is the lower part is these lava platforms, and you see it's all green, and the upper part is where the forests are. This is green as well. The rest of the island is not as green, it's quite barren. So what is going on there? What is the secret? Well, obviously the lower parts, the lower slopes, there we use irrigation, so water is added, but the upper parts, the green upper parts, that is actually the clouds. And I should point out that there is a secret here, and that is that a lot of the water, a lot of the moisture comes from the high clouds in the Canary Islands. It's called the Sea of Clouds, and Humboldt described this already. And here we can actually add a lot of moisture without having real rain to the volcanic soil, and that is part of the secret of these little volcanic fragments. They can keep this moisture. So here's an image of Tenerife from the peak of Teide volcano, looking down the spine of the island, and you see the Sea of Clouds there. And here's a Google Earth image, and the Sea of Clouds produces the crown of forest, this rim of forest that you see around the island. This feature was noted by Humboldt, as I said, and he drew these kind of wonderful sketches where he draws them as lateral continuous stretches of certain vegetation. So he noted immediately that in the lower parts you have these very lush tropical vegetations. Higher up you have more pine forests, and you can use this for agriculture as the Spanish settlers have done for many hundred years. So in the north of Tenerife, where you get a lot of the clouds coming in, it's extremely lush and fertile because of this combination of warmth, of volcanic soil, and an addition of water. Now, here's the trickery of the pecan, and that is once on a field work, on a field trip, there was a large delivery of pecan coming to the hotel, and I kind of looked at these bags of pecan, and when they arrived, they were rather dry. That's the picture in the lower left-hand side. But the next morning, you actually could see all that condensed water in there. So there was a lot of water inside the pecan, and that's the kind of thing. It stores a lot of water in the tiny little bubbles and vesicles inside these particles. And we did a little bit of work together with people from paleobiology. And here is an electron microscope image of one of these vesicles. And the vesicle here is full with little creatures, microorganisms. And these kind of microorganisms, they are helping to break down the particles, the volcanic particles, and they also lock CO2 inside these kind of rocks, which in turn is aggressive, and it breaks down the particles even further. And that then releases nutrients, which the plants via their roots can pick up. So we had a look at these kind of microorganisms, and I'm not very good at these kind of things, but with help from Micha Streng in paleobiology, we could identify many of these little creatures, and they were actually previously described as having a preference for certain volcanic rocks. So some of these microorganisms, they love volcanic rocks, and this is what we see there as well. And they are the ones that break down these volcanic particles and help plant growth by a biogenic as well as an inorganic breakdown of these particles. So the variety of microorganisms is quite magnificent, and they give a gradual supply of nutrients, and the important nutrients here is phosphorus, nitrogen, potassium, amongst some other elements. And usually if we add fertilizer, this is very tricky. Fertilizer runs off very quickly, and we are never quite sure whether we get the amount right. But here we have a natural fertilizer that gives things off very gradually, because you need to break down the particles in the soil. And the more of these microorganisms you have, the more living soil you have. And this is good for the plant growth. It increases the plant growth, but it also locks more and more CO2 in the soil and in the microorganisms. So here, very, very simply, I don't want to go into the chemical details, but if you add silicates that are contained in these volcanic particles and CO2 from the air, you produce carbonates in the end, and you release some silica, and the silica is then running off. The silica itself is rather harmless, and you lock, therefore, CO2 in the soil by adding these particles. Now, living soil, as I said, is the key ingredients here, and here we can have a much more fertile soil, and this is what happened on Lanzarote without people understanding it. This is what they really did. And if you look at the literature, there's estimates that this could be something that we could use a lot more widely. And some estimates like this from Rumpel et al. In 2018 argues that we could actually lock a lot of CO2 in living soil. And I'm not sure how good the estimates are. I found different kind of values in the literature, but this particular one says this could be up to about 3 to 7 gigatons of CO2 per year if we were to apply this rigorously on a global scale to our farmland. So, and here now to kind of bring this towards a wider discussion, the discovery of the bishop back then has really kind of changed the way agriculture works in the Canary Islands. But I should stress that the Canary Islands were a bit lucky, because it turns out this paper here from Beerling shows that not all volcanic particles are good. You need to have the right volcanic particles, those with high phosphorus and low nickel. Otherwise, you're actually adding a lot of poisonous residual elements in your soil. But luckily, the ones from the Canaries were of fine quality, and this has helped to produce good crops there. So the big question is, can we make such dry and barren areas useful? And this is what I want to spend the last few minutes with. And because it is a very simple kind of technique, I think we will see a lot more of this in the future, where we have areas which have groundwater problems, where we have food shortages. This could be a very simple way of really increasing crop yields. And this could also then help with kind of the environmental problems we're facing right now. So I think that this could be widely applied even in areas that we consider bone dry right now. Remember, the Canaries are on the same level, in the same climate zone as the Sahara. And here, this is kind of a little prediction about how areas on the planet might change over the next few years or decades. And the Sahara is actually going to stay dry. There's not much we can do. But there is the potential of actually creating crop farms by using the condensation that you usually have in the mornings, even in those dry areas. So I think within the next 50 to 100 years, there could be huge developments using these simple techniques. Now, in addition to the moisturizing dry areas and increasing crop yields, there is the CO2 aspect. And this has found some interest in the last few years. And there could actually be quite some potential for carbon reduction. And this wouldn't require any major technology. It is actually something that is very simple. You put material out there on the fields. Now, if you look at carbon budgets, we are burning a lot of fossil fuels, and this is causing atmospheric growth. And land and ocean sinks are not sufficient to keep up with that. Our land use is also problematic because many of the soils these days are actually deteriorating, and this is very, very tricky. So by managing to have the land sink increase by adding these volcanic particles, we could make a huge difference. And there's a very recent paper by Bieling and others, 2020, and they have done some modeling. Now we have to be careful. Modeling is also is usually associated with uncertainties. And the uncertainties here are given in the gray and green fields on the right-hand plots. But there could be up to about 2 gigatons of CO2 that could be removed just from the inorganic reactions that would be produced if we add these volcanic particles or volcanic ash to the cropland in these particular countries. So there's downsides, of course, and that is we would have to spend a lot of money for mining. We would have to crush these, so that will cost energy. And this kind of would also create volcanic landscapes that are deteriorating. So we have to think about that. And I should also point out, anthropogenic CO2 emissions are so large that even if we use all the cropland on the planet, we will not be able to compensate for the fossil fuel burning that happens right now. So we can, however, help the problem, and we can reduce the the atmospheric growth in CO2 by potentially up to 20% if we kind of use this. And here's something that I'd like to discuss with Leila, for example, later. I think that more experiments are needed, and this is also what some of the researchers out there say. So, and I have heard about the urban gardening project. So I was thinking that maybe that's something to try in some small areas or some subsection of it where the volcanic particles can make a difference there. And here I'm gonna kind of point out that on a global scale, this is important because those countries that have the largest emissions, that's kind of on the right-hand side here, they also have the largest croplands. So here there could be quite a difference. And I'm going to skip over the next one. If you have questions about that, I'll talk with you happily about that later. This is the amount of material that could be sequestered by this method in the various countries. But very briefly, I want to kind of touch in one slide about, is this applicable to Sweden? Well, Sweden is not very warm, so the reaction rates will be very slow, but the farmland is concentrated in southern Sweden, and there is some Jurassic alkaline basaltic rocks there. So in theory, it is possible, and I'm thinking about doing a little bit of research on modeling how impactful that would be if we would adopt methods like that in Sweden. So thank you very much, and I hope I wasn't too long, and I would be, of course, very happy to ask some questions. We have a little idea paper out there that we wrote a few years ago, and you would be more than welcome to have a look at this.